What is going on YouTube? Today I'll be showing you guys 25 tips to improve your Python code. Now, by the end of this video, you are guaranteed to learn something that will help you in your projects, whether it's stylistically, that is, to make your code readable and more professional, and also to make your code more efficient, which can help with interviews or personal projects. So if you are a beginner or intermediate programmer, I suggest you stick around for this video because I generally believe you are bound to learn something that will help with your Python skills. So that being said, let's get into it. Okay, first tip of this video is a very simple one, and that is just to organize your imports in Python. If you don't do that, oftentimes it can make your code a little sloppy, and I know it's a lot of beginners and intermediate Python programmers do this because, oftentimes when you're coding, you just want to focus on the code and you don't really care about the imports. But professionally, you may get flagged for this and it will make your code look less professional. So the standard for imports in Python is a very simple one, and that is you just want to organize your imports in 3 blocks. The 3 blocks go as is. So the first block is the standard library imports. These are all the libraries that come built in with Python. The second block, separated by one line, is just the third-party imports. These are just the pip install packages you have in your project, such as Numpy, Pandas, and other packages. And then third is just the internal packages you have in your code, such as functions from other files and that sort of thing. So you can see each block is organized as follows, and it's separated by one line, which is the standard. And finally, within each block, you want to sort by alphabetical order. So it's as simple as that. I think this is a nice tip to make your code look more professional, and it's really easy to implement in your project. So I suggest everyone does this if they are not familiar with it. Now jumping into tip number 2. Okay, so tip number 2 in this video is the PDB library, and I want to teach you guys how to use it, or want you guys to be familiar with it to debug your code dynamically in Python rather than use the built-in IDE debuggers or using print statements, because those other tools could be inefficient. And the reason I want to stress this point is because I did not find out about PDB until I was about a year and a half in my career, and now I use it every day, and it's a really powerful debugger to use in just about any Python programming environment. So you could just throw it in there. As long as you have Python, you can use PDB, and you could set a trace wherever you like, and you don't have to learn each IDE, because sometimes you don't have access to an IDE. Sometimes you're just running code in the terminal, and this can be a really powerful tool to dynamically see what is going on in your program when there is an error. And trust me, I do use this every day. So to use PDB, what you want to do is you just want to first import PDB. You don't have to pip install everything. And then you can just set a trace wherever you like in the program. So first, let me show you actually what the issue with this program is. We're just calculating the slope of a line, and it's just showing me the m and the x value. So if I go ahead and run this code, it's showing me an error. And let's say I want to go through this program and find out where the error is. So I want to set a trace somewhere. So in VS Code, what you typically do is you set this red dot, which I don't use anymore, and you go through it. I personally don't like that. But what you can instead do is just do pdb.setTrace to dynamically debug. And then I'm just going to go ahead and save this and run the code and show you how that works. Is that it sets the trace right after that PDB line. So it's showing me delta y equals y2 minus y1. I could run that line by hitting n, so it's going to calculate delta y. So I could see that delta y is fine. That's not where the issue is. So what is delta y? It's 0. And then I could run the next line to get delta x. So what is delta x? Okay, so I can see that they're both 0, and it's about to divide by 0. So if you know some math, you can't divide by 0. That's not correct in a mathematical sense. So it's going to show a divide by 0 error, which is expected. So what I can do instead with PDB is I can actually change values in the program in real time, which is cool. So I could say delta y equals 1, and then delta x equals 2. So we have access to local variables, which is really powerful. And so now I change the inputs to the return value, and now as a programmer I could see what is that going to give me. Is that what I want? Is that an expected value? So I can just go ahead and click continue. So C is just to continue through the remainder of the program. And once I click enter there, you can see it does show me a M and a B value. So that shows that my inputs are problematic and I would have to change my inputs. So that's just a very simple way you can use PDB. There's many powerful things. You can even write functions. You can write full-on code in PDB. It's just a really powerful tool that I want beginners to be familiar with, because a lot of beginners are not familiar with this. They're just used to debugging with print statements and IDEs, which I don't like. And if you get used to using PDB, trust me, you will fall in love with it. So that's a tip for debugging your code. Now let's jump into tip number 3. Okay, so tip number 3, this is actually a new feature in Python where you can now use match and case statements to greatly improve the readability of your code in conditional statements. Now, up to Python 3.10, this was not available, but if you are using Python 3.10 and above, I want you to be really aware of this feature and know it exists, because it can dramatically improve the readability of your code, especially if you're using if statement logic with a lot of nested if conditions. So here we're just going to show a simple example of how that improves the readability of the code. But in general, this is a really powerful aspect of the language that many people were asking for, because in other languages they had switched statements, and Python was notoriously known for not having that for a long time, but now they do. So in this example that I have here is I have a simple function that originally uses sort of the old logic before Python 3.10, where we were passing in a value and we wanted to do a bunch of if conditions, and if you get a specific match, you're going to return a specific statement that you're going to print here. Okay, so we just have 3 calls to that function. We run it, whereas in the second block of code here, it's essentially the same function, but what it's doing is it's actually improving the readability of the code, and instead we're just using the match in case. So we're passing what we want to match to, so that's just lang, and then we're comparing it to each case, and based on that we're going to print. So each block of this code is doing the same thing. So here we have the old logic, here we have the new logic, but to me, this one is greatly improved in terms of the readability, because this comparison is just much more clear and much more concise, and I could just imagine that generalizing really well to much more complex cases. So if we go ahead and run this code, I'll just show you that essentially gives you the same thing when we. So the first statement, you can become a web developer. That's just the print statement based on the inputs here. The second one is asking us for another match, so I could just pass in, let's say Python, and it should print you can become a data scientist. Okay. So simple as that. That's just one simple example. I just want you beginners to be aware of this because, oftentimes new features come out in Python, and Python is upgrading from 3.10, 3.11, 3.12, and sometimes you're not aware of these features, and this can actually save you a lot of time in terms of maybe you're doing a coding interview or improving the readability of your code dramatically. So just be aware that switch statements essentially exist now in Python, and try to take use of them. Okay, so tip number 4 of this video, I want to make people aware that Python essentially has a built-in binary search method that's pretty much almost the same thing as regular binary search, and a lot of people are not aware of this, and it can save you a lot of time. Even in coding interviews, if you don't have to implement binary search yourself, you can use the bisect method, which is built into the standard library, where you don't even have to pip install anything. You just say from bisect, import bisect left. So what this is doing in this example is I just have some sequence from 0 to 10,000 spaced out in 2 increments of 2. And what I'm doing is I am searching for a specific value in that sequence. So just a regular search, O of n times, so that's a linear time, that's not optimal in this example. And I'm going to check if the goal value, which index would the goal value be in this list. So I just pass a random goal value, let's say 1,000 in this case, and it gives me the index it would be in this list. And in the second case, I use the built-in bisect method to do that in logarithmic time as opposed to linear time, which we all know if you have been studying time efficiency, that logarithmic time is much more preferable than linear time. So that's just a simple example I have here. So it's just a binary search, essentially I'm doing. And I'm using the timeit library to test this a bunch of times to show that the bisect method is, of course, much faster than the brute force method, linear time. So if I go ahead and run this example here, we'll see that the bisect method does destroy the brute force method. So I just want to stress that this can save you time in an interview if you have to do something for binary search and you don't necessarily have to implement binary search from scratch. Just be aware that this exists, and let's move on to tip number 5. Okay, so tip number 5 of this tutorial is the Walrus Operator. So I want you to be familiar with it and know how to use it because it's a new operator as of Python 3.8 that can improve the conciseness and readability of your code. Especially in cases where you seek an input inside a loop continuously, like I have in this example here. It can make your code shorter and just more readable, and that's why it was created by the Python community. But if you're not using Python 3.8, you might have never seen this before, and it's really uncommon to see this used in projects. I haven't seen it too much in practice, and as we go deeper in Python, you'll probably see this more, so I just want beginners to be more familiar with it. This is the operator here, as you could see. Apparently it looks like a walrus with the 2 eyes and the tusk, so that's why they call it the Walrus Operator, also known as the assignment expression. So what it does differently than a simple assignment is that it evaluates the assignment and assigns it in one line of code. So as you can see here, this user input is being equal to the input and it's being evaluated to quit in one line of code as opposed to doing it in 2 separate lines of code here. And in this case, what we have is in the for loop, in the while loop, this is the older version before the Walrus Operator. So if we go ahead and run this, it's asking for a user input first, as we could see here. And then it's going to continuously ask for a user input until we put input quit in the first block. So let's say I put W and let's say I put R. And let's say now I put quit, so it's going to exit the first block. So we're done with the first block. And what you'll notice here is that the second block is the same thing as the first block, except it uses the new Walrus Operator just to make this code more readable and shorten the lines of code. In this case, it shortens it by 2 lines of code. And so it does the same thing. So we type in E, we type in Q, and we type in quit So that's just one simple example of where the Walrus operator can be useful. So what we say is user input walrus input. So that's kind of the terminology we use. We say A walrus B. Just be familiar with that, know it exists, because as we do get into deeper versions of Python 3.12, 3.13, whatever, you will see this more often, and beginners will be confused by this if they've never seen it before. And just try to use it in your projects to see where it can improve your readability, because trust me, it can. And yeah, so let's jump into point number 6. Okay, so next tip is you should use Enumerate when you can, and also be familiar with Enumerate if you've never heard of it. So Enumerate is a very useful method in Python to improve the readability of your code when you're looping through a list. And when you're looping through a list, oftentimes you need the index of the element in the list and the item in that list. So in this example I have here, what I have is I'm just looping through this list of fruits, and I'm just printing the index and the fruit. So a beginner, oftentimes maybe they would initiate an index, loop through, and maybe plus equals 1 to the index, and do an increment each time to do that, to get the index and the fruits. Also, what you could do is you can loop through the range and then index back into the list. But an easier way to do this is to actually use Enumerate to get the index and the item at the same time while cleaning your code. So let's just go ahead and delete this. We don't need that. Let's delete this. And let's just say enumerate, okay, fruits. And then we have to unpack the index and the fruits. So let's just do this as I. And that's just going to give us the same thing, more readable, more professional looking code, and it's simple as that. And what's cool with Enumerate, you can also start at a specific index if you want. So let's say I want to start at index 1. I go ahead and save that and run it. You can see it started at index 1. So just be familiar with Enumerate. It could save you some time in your code, make your code look better. Okay, next tip is I want you guys to consider using Numpy whenever you can when you're doing operations on arrays, such as adding elements in arrays, multiplying elements in arrays, especially when you're working with large arrays, because this is where you really start to see the difference between Numpy and regular array operations as opposed to looping through elements of an array. And that's because Numpy is really designed to do matrix algebra and perform array operations, because it has specific data structures that are efficiently designed to do this sort of thing. So when you are working with big arrays, maybe in a coding interview or in practice, just really consider that Numpy exists and realize that the efficiency is there when using it. So I have this simple example just to show a basic case of its efficiency, where in the first example, what I'm doing is I have these two lists where I'm multiplying each element in the list. So I'm going element by element in this first example without Numpy, and I am just multiplying it based on the index. And the second case, which is also more readable, I'm just multiplying the two lists by using the multiply operator. And because they are Numpy arrays, I could just multiply them like this. And I'm going to show you the efficiency here. It is an order of magnitude more efficient. So if I go ahead and I keep running this, I'll show you that every time the Numpy array produces a lower time. And this is just a very simple example, and this scales really well, especially when you're working with large data sets, which we often are in practice and even in coding interviews. So just be aware that if you do come across array operations where your arrays surpass maybe hundreds or thousands of elements, you do want to consider performing Numpy operations as opposed to regular Python operations. So just keep that in mind. Okay, so next tip is that I want you to be familiar with the cProfile library to profile your code in Python. So if you guys aren't familiar with the term profiling, it's probably something you do a lot, and you may have never heard of the term, but that's essentially just determining where the bottlenecks are in your code in terms of the resource utilization, such as CPU time, memory, and disk I/O. And this can be especially useful when we're working with complex projects. Here I just have a very simple example. I just want to show you how this library works. But also another note here is that there's also another built-in profile library which uses a Python profiler as opposed to a C profiler. And this C profiler is actually more optimal in the sense that it has less overhead. So it is better practice to use the C profiler to better determine where the resource allocation is in your program. So just be aware of that before going into this. Someone might tell you there's also a regular profile library. I think in my opinion, cProfile is much more efficient, and I think it's generally known in the community to be better than the regular profile. But anyways, jumping into this code here, what we have is a simple test prime function that calls the isPrime function. So I'm just trying to determine if a number is a prime number, and I'm doing this for numbers in range 1 to 1,000. And what I'm doing in the end is I'm calling cProfile.run. This is pretty much the simplest way we can call cProfile to give me some stats as to where the resource allocation is in this project. So let's just go ahead and run that. And what we could see here, something that stands out to me, is that something is being called 999 times, which is the isPrime. So me as a programmer, what I would realize is I would maybe have to determine ways to call this function less by using some optimization methods, by using some maybe memoization and other techniques to improve this calling to the function. So that's something that sticks out to me here. But you can imagine that this really applies to a general case. So if you're working with really complex projects where you really can't visually determine where the inefficiencies are, this could be a really useful tool in practice. Maybe not so much in coding interviews, but in practice, this can be really powerfully used to determine where to better optimize your program. So just be aware of it and try to use it in some of your projects, because trust me, it can help. Okay, so the next tip I have in this video is the catch-all unpacking operator. So this is an operator you may have never heard of in Python or seen before. It's this little star operator here. And what it allows us to do is it allows us to unpack the remaining elements of a list of unknown length or of known length in a very simple manner without having to index specifically into the elements of that list. So in this example here, what I have is I have sales figures across the course of 6 months. And what I'm trying to do is I'm trying to get the first, second, and third sales figure, and then I'm trying to get the remainder and just print that out. So as opposed to having to index the elements of the list, what I can do instead is use the star or the catch-all unpacking operator and run that. So if I go ahead and run that, we can see it gives us exactly what we want. It gives us the first three as expected, and it gives us the other. And what's also cool about this operator is we could just move it around in this unpacking. So let's say I want the first, second, and the last, and everything in between. So let's say last, okay, last. If I go ahead and run this, you can see it gives me 1,000, 2,000, and then 6,000, everything in between as expected. And what's also cool is if there's nothing left to unpack, it'll just give you an empty list. So let's say we go back to this third and we say star other. Let's go say third. So we're gonna unpack first, second, and third, 1,000, 2,000, 3,000, but the star operator is gonna see there's nothing left to unpack, and it's going to give us an empty list, which might be useful to know that there's nothing left to unpack. So in summary, this is just a useful operator when you're working with indexing elements in a list of unknown length and you want all the elements, and it actually improves the readability of the code because you don't have to index into the list. So this can improve the conciseness of your code, which is better practice as well. So just be familiar that it exists because you will see it a lot in more advanced programs in particular. Okay, so tip number 10 in this video, guys. We're almost halfway there. If you made it up to this point and you learned something, please like, comment, subscribe, and also congratulate yourself for learning new things in Python, because these are really good techniques you can really implement in your scripts to make your code better. So going into this tip here, what I have is I want to encourage you guys to use f-strings as much as possible. So first of all, you may have never even heard of f-strings. So that's pretty much the newest string formatting technique we have available in Python as of 3.6 or greater, which is in general cases better than previous string formatting techniques in every possible way, just generally every possible way. So what I have in this example is I'm printing 3 of the same statements here. In the first case, I'm using regular string concatenation. We're using plus signs. In the second case, I'm using a more improved version, which is, you guys have probably seen this with the string format method. And finally, I'm using f-strings. So you can see f-strings is the most concise as compared to all of them. I mean, the worst case scenario is just adding strings like this. You generally don't want to do that because it can get really cumbersome and messy. Then what we have here is the formatting method, which is a little better, but can still get out of hand, especially if you have a lot of variables. And finally, what we have here is the f-string. So f-strings are really easy to use in any string. So what we do is we just put an f at the beginning of the string before the quotes. And where we want to substitute the variables, we just put curly brackets and the name of the variable. It's really concise and really easy and nice to do. So if I go ahead and run this, let me just move my head here and go ahead and run this code. We can see that all these produce the same thing, but to me, f-string looks a lot more readable. And this generalizes really well when you're working with much more complex string formatting. So just to sum it up, f-string is the newer string formatting as of Python 3.6 or greater. So if you're not in Python 3.6, please get to it because there's a lot of benefits of using f-strings. It's a very concise syntax. It's really easy to use. As you could see, we don't have to do any formatting. We don't have to do dot format, all that sort of mumbo jumbo. It can really improve the readability, reduce the lines of code, which is nice. And generally, it's known to have faster performance than previous string formatting methods just because it's designed to be parsed very efficiently. And I think it's evaluated before runtime, which is nice as well. And finally, it has support for arbitrary expressions. So f-strings can support arbitrary expressions such as lists and dictionaries within the strings without you having to do additional formatting, which is nice. So it's a really good addition to the Python language. And I want beginners to realize that and try to use it as much as possible in their strings and their programs. Okay, so tip number 11, almost halfway there. And this tip is actually a very simple tip, but trust me, this one goes a long way because it's about variables and it's about properly naming your variables in Python, because I believe that's something a lot of beginners don't do, especially in coding interviews. What we're doing instead is we're doing these small abbreviations and other messy naming of our variables, which can lead to signs that we are an amateur programmer. So if there is a senior dev watching you code in a coding interview and you're just a mess with your variable names, that can be a bad sign, especially if you have a pickier dev. So what you want to do instead is just be really cognizant of the fact that there are Pythonic ways to name variables, and it doesn't take that much doesn't take that much longer to actually come up with nice names that make your program easier to read and signal that you are aware of this. So what I have in this example here is I have n equals 25, and I said if n is greater than 20, print classes over capacity. So now imagine nobody knows what this code is about and they're just reading my code on GitHub. They probably won't know what the heck n is. So what I want to do instead is give, first of all, a more descriptive name. So that's the first rule in Python. You generally want to try to have more descriptive names. Let's say I say number of students here, okay? But also, this is incorrect in Python because people coming from other languages such as JavaScript are used to camel casing. What we instead do in Python is we use underscore first of all, and everything is lowercase in a variable name. Okay, so now somebody reading my program will see that this does make a lot more sense, and they won't have to ask me as a dev, like, what is going on in your program? And this can be really useful on teams when we're working with big projects because you really want to be cognizant of the fact that other people are reading your code, and if they don't understand something, it could waste a team's time and lower efficiency of the team. So just be really aware that naming variables in Python is a really important thing, and take the time in interviews. It's just a couple more seconds to come up with more decent variable names. Go with the Pythonic standard because it could potentially impress the interviewer and just show that you are not an amateur programmer and you are aware of the fact that other people are reading your code. So it's just a really good habit to adapt, and you will get flagged in practice if you're not doing this. You know, people will say, why are your variable names so bad? And if your people are reviewing your code on GitHub, they will flag you a lot for that. So just start developing the good habit now with your variable names. Okay, so the next tip is to consider using generators over using lists in specific scenarios. And the reason I talk about this tip is because a lot of beginners are shying away from taking advantage of generators in Python, which can be a very powerful method to save memory allocation in your program and save time in terms of efficiency, which can help you in coding interviews because a lot of the failures we're getting in LeetCode HackerRank are pertaining to memory allocation, where we're using really large lists. And instead of doing that, you can consider using generators. They're a little different, but they can have some use cases where they could be much more efficient than lists. So I have this example here where I have two lists of numbers. They're the same list, but in the first example, what I'm doing is I'm getting the even numbers in that list by using regular list comprehension. So I'm going through each element in the list and dividing by 2 to see if there's a remainder to see if it's an even number. And in the second case, I'm doing the same exact thing, but instead I'm using a generator. So to use a generator, what you have to do instead is instead of surround it with square brackets, you're just going to surround it with regular parentheses, as you can see here, and that's the only difference. So if I go ahead, actually let me comment this out before we get into this time example here. If I go ahead and run this, we're going to get the same thing. In the first example, if I print even numbers, I'm going to get the whole list. In the second example, what's interesting about generators is you can only access each element in the list at one time. So if I go ahead and click print numbers, or print even numbers, or next even numbers, I'm accessing the next element in the generator. So if I go ahead and run this, let me just move my head again. I gotta stop putting it over there. We can see that it only gives me 2, and I can get the next element in the generator by doing another print. So if I do this, it'll give me 4, and so on until it's fully exhausted. So this can be really useful in cases where you don't need the whole list at that given moment, and it could save you time in terms of the program time and memory allocation because lists are more memory invasive. They use a lot more memory, and this can cause your program to crash in LeetCode or HackerRank. So what I have in this next example here is just to show you in terms of the time efficiency of building a generator over building a list. So we're going to see that building the generator is also more efficient. So if I go ahead and run this, I have the same thing where I'm just generating the list and the generator, but I'm using time it to see which one is more efficient. So if I go ahead and run that, we can see that creating a generator over a list is doubly more efficient in that case, so about 2 times more efficient. And yeah, you could see the usefulness there. Of course, it scales really well, especially if you have streams of data or potentially infinite data where you're getting data from a sensor and the list keeps increasing. Eventually, your programmer will crash, and that's a perfect scenario of where to use generators. So just be aware that you could use them. They're a really powerful tool, and many beginners shy away from them because it's more like an advanced thing in Python to incorporate generators, but it could really save you in your programs and in a professional setting. Okay, guys, tip 13. We are more than halfway through, so I just want to once again congratulate you guys for making it this far in this video. I know it's a long video, but I hope there's some good content here where you're learning a lot about the Python language and finding ways to improve your code in a professional setting and in a coding interview setting. So I'm really excited to make it through the next half of the video. But what I have in this example here is another method in Python specifically for dictionaries, the .get method, which can save you some time in terms of readability and make your code a little better and help you ease the ways you deal with dictionaries in Python. And you guys may have never heard of this, may have, but I'll just go over this example just to show you guys why it's useful and why you should use it more in your coding interviews. So what I have is I have this my dictionary where I have apples, bananas, oranges, and I'm just counting them. And I'm trying to retrieve the value in a dictionary. So in the first case, I retrieved the apple count by just accessing apple in the dictionary. So in that case, I got lucky. Apple is in the dictionary, so it prints a value. In the second case, what I have is I'm trying to retrieve a key in the dictionary that's not actually a key. So what typically Python is going to do, it's going to throw a key error. The key is not in the dictionary. And beginners in coding interviews, by the way, when I use the term beginner, I also am a beginner, so I'm not using it in a condescending way. So I do apologize because I realize I've been using that word a lot, and I don't want to make it seem like I am better than beginners, because me, myself, I am a beginner, and I'm also always learning about Python. You know, I've only been a professional for about 2 years now, or 3 years now also. So I don't want to seem like I'm better than beginners, because I also am a beginner. Anyways, what we do as a beginner Python programmer, what I used to do is I would do some if statement to check if a key is in a dictionary. Let's say I have a bunch of keys. I'm not sure if a key is there. I would say if key in dictionary, and then I would say if not, do some other operation. What you can do instead is, if you know there's a chance of a key error, you can use the .get method. So this is actually more efficient, and it's built into Python for this specific scenario, which is a really common scenario when dealing with dictionaries, because a lot of the times we don't know all the keys that are in the dictionary based on the program we're running. So if I go ahead and run this here, we can see in the first method we do get the key error. Once again, let me move my big head to the right there. So if we run that, we could see it's trying to access pair, which is not in this case, but that's not good. We want a cleaner way to do that. So as opposed to doing that, what I have in this example down here is I do mydict.getPair. So what's going to happen in this example is, if I go ahead and comment this garbage out, what's going to happen here is, in the first example, banana exists, so it's going to give me 2. Otherwise, with the .get, it's going to give me none because it can't find it. So we're going to avoid having to use the if statement nonsense, and just use this built-in method in Python, which is nice, that gives us that capability. So if I go ahead and run that, you can see it gives me none because pair is not in the dictionary. So an easy way to find out if a key doesn't exist. And what's also even cooler about the .get method is you can specify the return value if a key does not exist. So in the first case, it's automatically going to none. In this case, I would say I want it to give me not found. So that's another cool thing you could do with the .get method. Be aware of it and try to use it, because this is a really common scenario you see in coding interviews and in practice. Okay, so next example is pertaining to handling exceptions in Python. So the general standard of handling exceptions in Python is to be more specific with your error messages when you are dealing with exceptions. So know when you're writing your program which errors to deal with and which exceptions to throw back, instead of throwing a general exception as we have here, which is worse practice than throwing more specific exceptions as we have here. So this is a very simple way to improve the maintainability of your code, because it can help relay specific error messages to your user and help you expect specific error messages in your code to help better debug your code when there actually is an issue. So this is better practice, and a lot of beginners aren't doing this. They're just doing general exceptions. So if we go ahead and run this, if I do put some weird character here, it will throw an error. But in some scenarios, when someone is running my code, or when I'm going back to see if there is an error in my code, being more specific with my exceptions can help save me time and just make my code more maintainable. So just be more specific in your exceptions, make your code more professional, and that is tip number 14. Okay, so tip number 15 is to use the zip method when possible in Python, because this is a very powerful method that beginners are not aware of or have seen and don't really use that much, that allows you to iterate over multiple sequences simultaneously and combine their corresponding elements into tuples to access at the same time. So this can be a really powerful way to clean up the readability of your code and make it more maintainable. So what I have in this example here is we have fruits, quantities, and prices. So all lists of the same length. So oftentimes in Python also we are dealing with lists of the same length but with different information that all relate to one another. So that's also another reason why zip is useful, and it was designed for those scenarios. And what I want to do is I want to access the fruit, the quantity, and the price, and I want to get the total cost by multiplying the quantity and the price of the fruit, and print the fruit with the quantity times the price and the total cost using an f string. So what a beginner may do in this scenario is maybe they'll realize that all the lists are the same length, and they might iterate through the length of one of the lists and use the index to access other elements in the list, and it can get a little cumbersome and messy, especially when you're dealing with a lot of lists. So in this example, we just have 3 lists, and what we're going to do instead is we're going to use the zip to create a generator of these 3 lists and iterate through that generator and do exactly what we want in a much cleaner fashion. So if I go ahead and run this, the first thing that's going to do is going to print this statement, and then it's going to print this 3 times. Okay, so let's go ahead and run that. So we can see it does print the apple, and it stitches all of them together with the quantity and the price. Same thing with the banana and cherry, and it gives us what we want in the second print statement 3 times in a row. So it's a really powerful method to maintain the readability of your code when you are dealing with lists of the same length and you want to loop through those lists, and there's some relation with those lists as well. Okay, so tip number 16, this is not necessarily a tip, it's just something I want you to be aware of, and that is this else statement here. So you're probably confused because you've probably never seen this before. I didn't until recently, and this is actually an else after a for loop and a while loop. And you probably thought before this, if you were a beginner Python programmer, that you can only have else and if statements. Well, you can actually have else after loop conditions, and what that means here is that this else is actually executed after this for loop is exhausted. So if this for loop is fully exhausted, then it'll else execute this print statement. And that's what's going to happen in this example. Same thing with this while loop. If this while loop is fully exhausted, that is, it gets to the break condition here, and doesn't execute anything inside. It does not exit anything on the inside. It'll instead go to the else statement and print blast off. So going on this example, we're just iterating through the fruits, and we say if fruit equals orange, then we want to say print we found an orange. Otherwise, else, it's going to say we didn't find an orange. So if it goes through all these elements and does not find anything, it's going to execute this else statement. So let me just comment this first before you get confused there and just show you how that works. So it's going to say we found an orange, but let's say we want to look for a raspberry. I don't know, I thought of raspberry for some reason. And I go ahead and run that, it's going to print we didn't find any oranges. So it exhausted everything in the fruits, and it's just going to go to this else statement. So it's the same thing with this while loop. It's the same exact principle. So it's going to keep going until it exhausts the whole while loop, and then it's going to print blast off. So same concept there. So that's just a funny fact or funny thing you could do with the Python language that nobody really does. And generally it's considered, from what I heard, bad practice to do that. And there's only very specific scenarios where you want to use the else condition in a for loop and a while loop. So if you thought that was pretty cool, like, comment, subscribe, because I thought it was. And it's something I share with a lot of Python programmers, and people who've been programming for years actually don't even know this exists. So fun fact. Okay, so the next step I have is to use docstrings in Python. So for those of you guys who don't know, a docstring is a string literal that occurs in the first statement of a module, function, class, or method definition that pretty much explains what is going on in this piece of code to better maintain the readability and the longevity of your code, because one day, hopefully, your code will become legacy because it's such good code, and future developers, maybe even your future self, will want to add features to this code, and they want to better understand what's going on. So it is a more efficient way for people to work on your code because they can have a better understanding of simply what is the code doing, what are the parameters. So in this example of a docstring with functions in particular, what I'm explaining is first, what is the function itself? What is it doing? It's a very simple function. I'm just adding two numbers, but you can imagine with a much more complex function, this becomes exponentially more useful. And then I just explain the parameters, what types they are, num1, num2, they're both integers, and I just give a brief explanation. Don't make it too long because being too verbose is actually bad practice in docstrings. And then finally, I explain the return, which is an integer, the sum of num1 plus num2. So my future self would probably thank myself because a lot of times you go back to work on your own code and you forget what the code is doing. So this can save you time as well. And this is really good in a professional setting where you have time to write this. Maybe not so much in a coding interview setting. I mean, you could do this in a coding interview if you have time towards the end to impress the interviewer, to show them you know what a docstring is and you're using it to help maintain the maintainability of your code. So that's just a thing you should do to better conform to Python PEP 8 standards. And what's also cool here is that Python actually expects docstrings as well. So if I go ahead and run this print statement, print help, add numbers, which is the name of the function, it actually goes and looks for the docstring. So even Python itself is looking for docstrings, and that just goes to show you it is a very important feature of the language that some people often forego. Okay, so the next tip I have is to be aware of the fact that the ordering of your Python dictionary keys is not necessarily as you expect in all Python versions. So what I mean by this, in newer versions of Python, it inserts our keys in insertion order. So if I go ahead and run this code where I have a dictionary, I print the keys and I insert a new key value and I run it, you can see it prints it properly. So A, B, C, and then D. And this is because I'm using Python 3.11. Earlier versions of Python 3 and Python 2 actually have really unexpected behavior in terms of the key ordering. So if I go ahead and I run the same code in a Python 2 interpreter, and I go ahead and execute this, we'll actually see that C becomes before B, which doesn't make any sense because we had A first, B first, and then C. And so that's just a really unexpected behavior, and I just want you to be aware of that when you're writing code online on GitHub, and maybe try to use another method such as order dict in the collections library, I believe, to enforce the ordering of your keys, because other developers downloading your code may be using an older version of Python 3 or even Python 2. Believe it or not, people are still on Python 2. So just be aware of that fact. And also when you're in coding interviews, you might be using an interpreter that's actually not Python 3.11. Maybe it's Python 3.2. It's an old interpreter, and you're expecting some ordering of your keys. And actually, I did this once during a mock coding interview, and I was like, what the heck is going on with my keys? Why are they not in insertion order? And I realized Python, that version of Python, was not ordering my keys. So I want you guys to be aware of this as well if you were not. Okay, so this next tip is pertaining to list comprehension. And for those of you guys who don't know what list comprehension is, it's a very useful technique in Python that allows you to create a new list from an existing list in a very readable and concise way without having to write boilerplate code. So it pretty much allows you to apply filters and transformations to an iterable object so you can come out with a new list that meets your specific requirements. So in the first example, I have an example of a good practice of where you can use the list comprehension as opposed to writing a for loop to do this. So we have these numbers, and I'm just trying to square each number in a list and return the squares and print it. So this is a perfectly good example example of why you'd use list comprehension to improve the readability of your code. But when beginners often find about list comprehension, sometimes they go crazy with it and they throw a bunch of sub expressions in there and they think it's a good idea, but it's really not. So the general practice when using list comprehensions is to only use at most 2 sub expressions when you are forming your list comprehensions, because anything other than that really ruins the readability and the purpose of using list comprehension, which is the conciseness and readability of your code. So you can see in this second example here, if you're reading it, it's really confusing as to determine like what is going on from an outside perspective unless you really analyze it for a few moments and see what's going on. So I'm going for each element in the row and I'm seeing if the elements are divisible by 3, and I'm only returning that if the whole row itself, the sum of it is greater than or equal to 10. So it can quickly get out of hand. I mean, it does give me a proper result, but it would be better in this case to simply use a for loop to be more showing of what you're trying to do in this logic, as opposed to saving lines of code, when in reality, saving lines of code isn't always better code. So I just want you to keep that in mind for the best practice when using list comprehensions. Okay, so speaking of comprehension, the next tip is pertaining to dictionary comprehension, which is just another technique I want to share with you guys, because people use list comprehension, but a lot of people aren't aware that you can also do the same thing with dictionaries to improve the conciseness of your code. And also, you don't have to write any boilerplate code as you did with the list comprehension. So it's the same thing, but with dictionaries. So what I have in this example here is I have original dict, and I could do some filtering with dictionary comprehension where I'm trying to see if the value, the value from the key is divisible by 2 in the first one. In the other case, what I'm just trying to do is I am uppercasing the key, and then I am timesing 2, multiplying by 2 the value. And then that's a nice way to do that, as opposed to having to go through a for loop and do that. And in the second example, you can actually flip the keys and the values very easily by doing dictionary comprehension as well. So that's just a cool thing you can do that some people aren't aware of. They're just only aware of list comprehension. So just be aware of the fact that you can do dictionary comprehension as well. Okay, so if you made it this far in this video, I just want to say congrats. We're on point 21, 5 more to go. And these next 5 points will be quicker, but they'll also be useful as well. So I just want to say thank you for watching the video up to this point. Now, point 21, like I said, is going to be simple. It's just a really simple styling thing that I noticed some people on LeetCode and HackerRank are showing in their solutions, which is to essentially have a one-line for loop or a one-line if statement, which you can, but this is bad practice, and it's always better to split your for loops and if statements or while loops into multiple lines, because it makes the code just more readable. And you'll see that I actually have a styling tool here, so if I go ahead and try to run this, it'll automatically split it up to other lines because it knows it's bad practice to do that. So if I go ahead and run it, we can see that it automatically splits it to other lines there. So it is generally known that we should split our if statements and loops across multiple lines. Okay, point 22, quick styling tip as well, is to avoid using the equal empty bracket sign when you're trying to see if a list is empty, because this is actually redundant and slightly bad practice. It's kind of a nit, it's not a big deal, but it is generally better just to say if not some list to check if it's an empty list, because this also evaluates to true if it's an empty list. Okay, so as opposed to doing equal empty list, you can just write this, which is better practice, and we'll end up getting the same thing. So if I go ahead and run this, this gives me the correct thing, which is better, but you'll see it's the same case as it was before where we compared it to an empty bracket. And this lesson pertains to the same thing with an empty string. So don't check if a string is an empty string by comparing it to an empty string. Just say if not string, which is slightly better practice. So that's a very simple tip. Let's go to point 23. Okay, so tip 23 is pertaining to line length in Python. So some of you may have already heard of this, but the PEP-based standard for line length in Python is 79 characters. And I know it's a lot of beginners, and I remember myself when I was really new to Python, I was just absolutely crushing this limit and going maybe in the hundreds of lines. It's generally okay if you're plus minus some characters, but if you are well over 79 characters, you want to consider splitting your lines across multiple lines, because this greatly improves the readability of your code. So other people reading your code don't have to scroll to the right of the screen, which is just generally inconvenient for other people reading your code. So one good way in Python, one recommended way to do this is just to use parentheses to split the expression across multiple lines. So if I go ahead and save this, my styling tool will do that for me. So you could see here. And another way to do that, which is generally less recommended, is to use backslashes, which you might see, but it's just general practice to use parentheses instead. So that's just a quick tip for you to improve the readability of your code. Okay, so tip 24 is also something you may have never even thought of. It's actually adding a new line to the end of every Python file. And actually adding a new line is considered in the PEP-8 styling guide to be the standard. So it's recommended that you actually just simply add a new line at the end of every file. And the reason this is the PEP-8 standard is because in some cases it can actually prevent some text editors or compilers from having issues reading a file without a new line character. And so adding a new line character at the end ensures that these issues are avoided with your code. Also, it's more readable in the sense that adding a new line character at the end of a file visually separates it from the end of a file from other content that may come after it. So let's say you concatenate this file from other files, it might be a nice way to separate them. So it's just a really small detail, but it is the PEP 8 standard, and it's something that beginners aren't aware of. So just include a new line at the end of your file to better conform to PEP 8 standards. Okay, so point 25, final point of this video. So exciting. We just got through 24 lovely points. And point 25 is just to practice. So no code. Yes, I'm serious about this point because, and I generally think it's the most important point of this video, because without all the practice, you'll never retain all the information you watch in a YouTube video, especially a long one like this, because it is a lot of information. And if you're not applying it to your projects and doing it every day, it will slip out of your brain. So my advice is to simply apply it to your projects, whether it's work or school, or even in coding interviews, because a lot of these points are simple and you can quickly apply them in coding interviews, which can help you in coding interviews and potentially help you get a job, who knows. And then also number 3 is I want you to flag your coworkers or teammates when you're doing code reviews, because a lot of people are shying away from flagging people to improve the readability of their code or tell their coworkers to add a new line at the end of the file, which I understand. I have that issue as well. Sometimes it seems a little extra to tell people to do these things, but trust me, over time you will get more comfortable saying these things, and other people will follow in this cycle and just generally improve the Python community coding abilities. So everyone will get better if you flag people for improving the maintainability and readability of the code. So it's okay if you do that. So last comment I just want to say is, if you did watch this whole video from end to end, I just want to say that means so much to me as a new educator on YouTube, because as you know, being new on YouTube, it's not easy with all these brainiacs and other Python coders showing amazing Python skills and showing you guys how to do things as well. So if you took the time to watch this whole thing, it means so much to me. If you could leave a comment and tell me how it helped you, or leave a comment as well and tell me what you want to see on the channel, that would also be greatly appreciated. If you're not subbed to this channel, please sub. That would be awesome if you did, because in this video, or on my content in general, I generally try to find ways to help coders. None of that BS. I'm not trying to recycle information online to feed you guys garbage. These are genuine points that I think, I actually got these from a textbook I've been reading. It's a pretty intermediate textbook. And so I thought I'd share this with everyone, because these are things I never learned until I read this book, and I'd never learned until I was in practice as a software engineer. So hopefully you guys did learn something. That would mean a lot to me if you did, and if you let me know about that. So that being said, as always guys, stay tuned. Thanks for watching. Let me know what you want to see in the comment section down below. And as always, you know what I say, take it easy.